In this video, we are going to review sign charts. Now, sign charts are a tool that can be used to determine a few things about a function. It can determine when the function's positive, when the function's negative, and with a little bit of modification, we can incorporate when the function is undefined. Now, sign charts are well used within mathematics, so much so that there's many different ways to create a sign chart. If you know a way of making a sign chart that you are comfortable with, stick to that method. You don't need to learn a new method to create a sign chart. If you are new or unfamiliar with sign charts and would like to learn a way to solve a sign chart, this is a technique that you can use. To create a sign chart and solve a sign chart, we're going to use 4 steps. First step we're going to do is create a single fraction. Then, when we have that single fraction, we're going to factor the numerator and denominator. Second, we're going to create a sign chart listing out each factor from our fraction that we created and indicate the points where the function, each of the factors equals 0. The factor can come from the numerator or denominator. It does not matter. Then we're going to complete the sign chart of each factor. So instead of doing the whole sign chart all at once, we're going to do the sign chart for each factor or complete the row for each factor. And to do this, we're going to use a technique where we analyze the right end behavior of the factor. Then we're going to determine if the left end behavior is the opposite of the right end behavior. And then we're going to determine if the left end behavior is the opposite of the right end behavior, where the factor equals 0. Once we've completed each row or looked at the sign of each factor, then we're going to complete the sign chart by doing sign multiplication, or taking the product of the signs. Okay. And to understand this process, we're going to go through 3 questions together. So to start, we have A, which is f of x equals 1 over x minus 1 over x squared. Well, the first step is to make this equal to x over x squared minus 1 over x squared, which equals x minus 1 over x squared. We have shown that f of x equals x minus 1 over x squared. Now we can create our sign chart. And to create our sign chart, we have 2 factors. We have x minus 1 and x squared. And these factors here, x minus 1 equals 0 when x equals 1, and x squared equals 0 when x equals 0. So my 2 points that I'm going to emphasize are 0 and 1. Okay? And now I'm going to look at each factor. Now, for the first factor, I'm going to determine what's the right end behavior. And the right end behavior for a polynomial, we can determine using our leading coefficient. Because our leading coefficient is a 1, the right end behavior is positive, because 1 is positive. With our polynomials, if it's odd degree, the left end behavior is the opposite of the right end behavior. So our left end behavior is going to be negative. So we do change sign. And now we determine where. And it can only change sign about a point where this expression equals 0. So we can only change sign at 1. So we go from positive to negative, changing sign at 1, and we've completed our line. Now for x squared, once again, I look at the right end behavior. It is positive. I look at the left end behavior. It is also positive. So here, it doesn't change sign. So even though it equals 0 at 0, it doesn't change sign, so it's positive everywhere. To complete the sign chart, I do sign multiplication for each column. Negative times positive is negative. Negative times positive is negative. Positive times positive is positive. And now what I'm going to do is I'm going to add one last thing to help us when determining where the function's undefined or equals 0 or so on. Whenever the 0 is on the denominator, we write a little ud to say undefined here. And whenever the numerator is 0 and the denominator is not 0, we put a little 0 to say, hey, my function equals 0 here. Okay. Now we're going to answer our three questions. Where is f of x greater than 0? Where is f of x less than 0? Where does f of x equal 0? And where is f of x undefined? So greater than 0, this is x is in the interval 1 to infinity. If I create a sign chart, if I look at the sign chart and I think of it as a number line, not including here, positive. That's where I am greater than 0. Where am I less than 0? Well, I'm less than 0 everywhere less than 0 and between 0 and 1. My function is negative here. While this is x is in the interval minus infinity to 0, union with 0 to 1. And where does x equal 0? Well, we can just look on our graph and see that it's 0 at x equals 1. So x equals 1. And where is it undefined? X equals 0 is where it's undefined. So this one wasn't too bad. In our next example, things become a little bit more interesting. B. So with g of x equaling e to the x minus 1 over x squared minus 3x minus 2, we actually need to factor the denominator here. So with factoring the denominator, we get e to the x minus 1 over x minus 1, x minus 2. Okay. It's really tempting to create a sign chart using the factors e to the x minus 1, x minus 1, and x minus 2, and just creating it about the points 1 and 2. We're really tempted to say, well, that's the only place where it can be. But if we look at e to the x minus 1 equals 0, well, this implies that e to the x equals 1, which implies ln of e to the x equals 1, which implies x equals, or sorry, ln of 1, which implies that x equals 0. So we actually have a third point. We have 0, 1, and 2. Okay. Now, for this example, I've got to go through my three questions. E to the x minus 1, what's the right end behavior? Well, that's positive. What's the left end behavior? Well, the left end behavior of e to the x is 0, minus 1 is negative 1, so I'm negative. And where do I change sign? I change sign when this factor equals 0. And we can see that happens when x equals 0. So I change sign, I go from positive to negative when I cross over 0. Okay. Now, with x minus 1, the right end behavior is positive, the left end behavior is negative. So I change sign, and I change sign about 1, because that's when x minus 1 equals 0. So plus plus negative. And with x minus 2, I am positive. I change, and on the right end behavior, my left end behavior is negative, and I change sign at 2. Now I can do my sign multiplication. Negative, 3 negatives is negative. 2 negatives is positive. 1 negative is negative. 0 negatives is positive. And now for each of these points, I'm going to put a little UD for 1 and 2, because that's from the denominator. And I'm going to put a little 0 at 0, because that's where the numerator equals 0. And now from this chart, I can answer my 4 questions. G of x is greater than 0 when x is in the interval 0 to 1, union with 2 to infinity. G of x is less than 0 when x is in the interval minus infinity to 0, unioned with 1 to 2. G of x equals 0 when x equals 0, and g of x is undefined when x equals 2 or 3. Sorry, when x equals 1 or 2. Last but not least, we have question C. So here we have h of x equals ln of x over x minus 2. Now, here we actually have an added wrinkle to this problem that we're going to deal with our sign chart. The added wrinkle is for ln of x to be defined, x must be greater than 0. And also, ln of x equaling 0 implies e to the ln of x equals e to the 0, which implies that x equals 1. So we have a root on the numerator of x equal 1, but we also have a domain restriction from the ln. But we can still use this to create a sign chart. But however, the sign chart is going to have 3 different numbers now. It's going to have 1 and 2 for the numerator equaling 0 and the denominator equaling 0 respectively. But it's also going to have a 0 for when ln of x is undefined. Now I have my two functions, ln of x and x minus 2. Here, ln of x, my right-hand behavior is going to be positive. My left-hand behavior is undefined, and I'm going to put a big X here. When I go off to negative infinity, it's not defined. However, I know that ln looks kind of like this. So in my head, I'm going, okay, yes, it's undefined below 0, but it's negative just before 0 because of my knowledge of ln functions. And again, now we have this negative positive. Where does it change sign? It changes at x equals 1. So I'm positive up to x equals 1. For x minus 2, I am positive. My right-hand behavior is positive. My left-hand behavior is negative. And I change sign at x equals 2. So I go from positive to negative about x equals 2. And now I can do my sign chart multiplication. Positive, negative, positive. And here I'm going to put an x for not defined. Last thing to do, undefined. And with ln of x is undefined at 0, and it equals 0 at 1. So I get undefined, 0, undefined. Okay. Taking this resulting sign chart, we can complete the questions. H of x is greater than 0 when x is in 0 to 1, union with 2 to infinity. H of x is less than 0 when x is in the interval 1 to 2, and h of x equals 0 when x equals 1, and h of x is undefined when x is in the interval minus infinity to 0, unioned with the set containing 2. And we have our sign charts. This is just going through 3 examples using these steps. If you'd like to learn more about these steps, feel free to come to talk to office hours, specifically Thomas's office hours. He'll be happy to go over more and more of these sign charts. Again, I want to iterate that any sign chart works. As long as you have a valid sign chart, you know how to use it, that's okay. But this is the sign chart that Tom likes to use, and he finds it quite effective.